Let's begin with something simple. The area of regular shapes. We all know how to find the area of a rectangle. It's just length times width. For a triangle, it's half the base times the height. These formulas work perfectly when the shapes are regular and well-defined. But what happens when the shape isn't regular? What if the top of the shape is curved, wavy, like this? We can't apply the standard formulas here. There's no base and height in the usual sense. So, how do we find the area under a curve like this? This is where a brilliant mind stepped in, Sir Isaac Newton. He realized that to deal with such irregular shapes, we need a new kind of mathematics. Let's try to estimate the area under a curved graph. We can begin by dividing the shape into rectangles. Let's use just 4 rectangles for now. The total area of these rectangles gives an approximation of the total area under the curve. But it's not perfect. There are gaps, and there's error. So what can we do to reduce the error? Simple. Use more rectangles. The more rectangles we add, the better our approximation becomes. The rectangles hug the curve more closely, and the total error gets smaller and smaller. Now imagine this. What if we used infinitely many, infinitely thin rectangles? In this case, the approximation becomes perfect. This process of summing the areas of infinitely many tiny rectangles is what we call integration.